Let's look at OpenStax University Physics Volume 2, Chapter 13, Problem 40. A coil of 1000 turns encloses an area of 25 square centimeters. It is rotated in 0.01 seconds from a position where its plane is perpendicular to Earth's magnetic field to one where its plane is parallel to the field. If the strength of the field is 6 times 10 to the negative 5 Tesla, what is the average EMF induced in the coil? Let's write down our knowns and unknowns. So we know that the number of turns is 1000. We know that the area is 25 square centimeters. We know that it is turned in an amount of time of 0.1 seconds from a position where its plane is perpendicular to one where it's parallel. Okay? We know that the magnetic field is 6 times 10 to the negative 5 Tesla. And we're looking for the induced EMF. So let's look at the diagram. We're told that we have a coil in a magnetic field, in the Earth's magnetic field, and originally its plane is perpendicular to the Earth's magnetic field. So that means that the coil is like this. And then later on, the magnetic field hasn't changed direction, but the coil is now parallel to the magnetic field, something like that. So this is hard to see. I'm going to draw the area vector for the coil. So the area vector is this way and this way over here. Remember that the area vector is perpendicular to the area. And this is the magnetic field. All right, so it's a Faraday's law problem. So we'll write out the induced EMF. It's negative N delta phi B delta T. So we have 1000 turns. We have to leave N in here. So this becomes negative N delta magnetic flux. So that is BA cosine theta divided by delta T. So now we know that we have a value for the magnetic field, we have a value for the area, so we don't have to write out what the expression for the magnetic field is because we have the value for it. And now we have to evaluate which of these things change in this problem. Magnetic field is constant, it's not changing. The area is constant, it's not changing. It's the orientation between the area and the magnetic field that is changing. So everything else I can take out of my delta symbol. So the EMF is negative NBA. And then I'm left with delta cosine theta over delta T. So that is negative NBA. Delta means final minus initial. So it's cosine final. And that is the angle between the magnetic field and the area vector. So that's 90 degrees. Minus cosine initial. So here the magnetic field is in this direction, the area is in this direction, so the angle between them is 0 divided by delta T. So we know that cosine 90 is 0, and we're left with NBA cosine 0, which is 1, divided by delta T. So now let's plug in our numbers. N is 1000, B is 6 times 10 to the negative 5 Tesla, area is 25 times 10 to the negative 4th square meters, cosine 0 is 1, divided by delta T, which is 0.1, and we end up with 15 millivolts. So there will be 15 millivolts induced in the coil.